Okay, this is part 3 of calculating an alkaline glaze recipe from this book, Ceramic Processes by Mary Chase Stratton, somewhere around 1940, 1941, maybe 1938. This is Lewis Katz. Parts 1 and 2 are before here on the site, so feel free to go back if you want. We're looking at this glaze recipe here by MC Stratton. We've recalculated it using container glass. And we're getting ready to look at it compared to some limit formulas. It's going to be a little bit hard to compare because most glazes in our repertoire do not have this much soda or potassium. And so we're going to have to punt when we get over to the limit formulas. But if you take a look here, you'll see that 8.69, this number is high for a thermal expansion number, and it's going to cause crazing on our clay body here. I would expect it to craze a whole lot with a number that high, but you really have to test it to be able to tell. We threw the copper carbonate in here just to see how it would turn out in such a highly alkaline metal glaze, a KNAO dominated glaze at cone 10. So we're going to look at it that way, and we are going to send this over to the limit formulas. Here we have it in the limit formulas, and you can compare it. We're going to compare it first to cone 10 Celadons. And if you look at the cone 10 Celadons, we're right in the money here for the alumina and silica, probably the first thing we should look at. We know the fluxes add up to the same number of moles. They add up to 1 mole as compared to these. So we know that on average we're okay here. But most cone 10 Celadons are really dominated by the alkaline earths, usually calcium, well, always calcium oxide, but sometimes they have a little bit of magnesia. We actually have more magnesia than they call for on average, and a little less than half the calcium. And wow, something here is goofed up. What do we have to do? There we go. There's the KNAO numbers. And if you look at them, you'll see that we're way over on both of those. And they make up for our lack of calcium along with the magnesium. So we want to just look at this in comparison to some other recipes too, just to make sure that we know what's happening. We're going to look at it with cone 6, glossy glazes, clear glossy. Here we go. Here's a cone 6 clear glossy glaze. And you know, it's not looking that far from here. The silica is a little bit high, just a hair. The alumina's right on the money, but it's got no boron, and boron acts as a big flux at cone 6 and will lower the melting point a considerable amount. This looks about like it does at cone 10. We're actually looking closer in the fluxes to this recipe than we were to the cone 10 recipe. So we're going to have to see what happens. It could be that this makes a better cone 6 formula, and I can't tell you without testing. But that's exactly what we're going to do. So with that, going back to the recipe and recapping, we put in Mary Chase Stratton's glaze. It had sodium silicate rather than container glass. We ran it over to the glaze calculator and changed it out for container glass because container glass is a really great fit for getting sodium and potassium, and of course you're recycling, but maybe by the time you get all the energy into grinding it up in your studio, it's not such a good deal. We used elastonite in part really because I've got a big container of elastonite, and I'd rather have a little container of elastonite and use whiting, so I'm going to use it up. And in part because it'll cut down on bubbling and other things, and it had some magnesia in it. So, you know, a lot of little things went into that decision. Anyways, I want to thank you for coming today and watching my my Jingcast here, and hope you have enjoyed it. We're at LewisKatz.net. That's LOUISKATZ.net. Thanks.